Welcome back. Let's start talking about section 2 mixtures. This lecture will be done in 2 pieces because it's a little bit too long for one, I believe. So let's talk about mixtures. So when we make coffee in the morning, hopefully we can make it without any grounds left in the cup. And we use hot water to extract the coffee from the ground beans. And then we, of course, add other things to it. And why aren't there grounds in the coffee cup? We'll come back to that in a little bit. So, how can mixtures be classified? And you're going to have a good bit of vocabulary that you have to apply in this chapter. A salad bar, which probably we can't even have anymore, will have things like lettuce, tomatoes, cheese, peppers, onions, all sorts of things. And each customer can go down the line and add what they want to their salad. And if you don't like green peppers, you just don't add them. So each mixture, each salad that you make is a mixture of different kinds and amounts of components. So a mixture is a physical blend of 2 or more components. Most samples of matter are mixtures, and that means that some are easier to recognize than others. You can easily see chicken noodle soup would be a mixture of chicken, noodles, broth, maybe some carrots, etc. My soup always has lots of carrots. Recognizing that air is a mixture is a little more difficult, but you do know that it has oxygen as well as carbon dioxide, and the major component of it is nitrogen. And we can have, like today, a lot of water vapor in the air, or in the winter it could be a little drier. And so it can vary the amount of water vapor. So based on the distribution of the components of the mixture can be classified as either heterogeneous or homogeneous. And this gets a little trickier. So chicken noodle soup would be heterogeneous. We have the part that is a liquid or the broth, but then we have the solid noodles and chicken and carrots. And so each spoonful would be a different amount of chicken and noodles and hopefully the same amount of broth. So a heterogeneous mixture is a mixture in which the composition is not uniform throughout. Another example of a heterogeneous mixture would be like a granite countertop. Why we like granite is that it has those various areas that are lighter and darker, and it has veining running through it. So, homogeneous mixtures. If we just look at olive oil, the olive oil itself is a homogeneous mixture. It has nothing in it but olive oil. So olive oil doesn't even look like a mixture, does it? The same would be true for vinegar. Vinegar is a mixture of water and acetic acid, and the water dissolves the acetic acid, making it a mixture, but it should hopefully have the same composition throughout. When I mix, however, olive oil and vinegar, which are both homogeneous, I would the mixture is in which the composition is uniform throughout. So both of these are homogeneous mixtures. But if I were to mix them together, and each of them would be called a solution. But if I mix them together, they would not be homogeneous anymore, would they? Many solutions are liquid, but they can be gases and they can be solids. When we have a alloy, something like stainless steel or bronze, we have a mixture of 2 different types of metals, and we make this into a homogeneous mixture by heating it up, mixing them together, and we get a compound or a substance that's not a compound. We haven't made any new bonds, but it is a mixture of 2 or more metals that give it better properties than if it was just the one metal. The term phase is used to describe the sample with uniform composition and properties. So homogeneous mixture consists of a single phase, something like water or vinegar has acetic acid dissolved in water, but it's in a single phase. It's all liquid. Heterogeneous mixtures consist of two or more phases. So while the vinegar is a homogeneous mixture and oil is a homogeneous mixture, oil and water mixed together is a heterogeneous mixture because the oil will float on top of the water, creating two different phases, the oil layer and the liquid water phase. At the beach, you realize that both ocean water and sand are mixtures, which is homogeneous and which is heterogeneous. That's a good question. I like it. So salt water is homogeneous mixture, but the sand is a heterogeneous mixture. And when you look at it, you can see the other debris, you can see different colors. If it has a variation in color, then it has to be heterogeneous. How can mixtures be separated? We have a couple of ways of doing that. In fact, your lab for this unit is about quick lab called mixtures, and you're going to separate ink. If you have a salad containing ingredient you don't like, you can remove it with a fork. I can pick out those green peppers that I don't like. But many mixtures are not as easy to separate. And how do we do it? Well, and if I wanted to separate oil and vinegar, for example, I could decant or carefully pour off the top layer, which is the oil layer. Or I could cool the mixture until the oil turned to a solid, and then I could scrape off the solid oil from the top and have just the liquid in the bottom. So pouring off the oil takes advantage of that. It floats or its density is lower. Cooling it also takes advantage of another physical property, which would be its melting point or freezing point. Differences in physical mixtures can be used to separate mixtures. So when I make coffee in the morning, there's a coffee filter. I pour the grounds in there, I add hot water, and I end up with coffee in the bottom of the container and the grounds are still separated. And so this is called filtration. So filtration, filter paper is used, and that filter paper will often be held in a funnel, and we pour the mixture through. The solid particles that cannot pass through the filter paper will remain on the filter paper, and the rest of the particles will pass through, and that would be the liquid phase. And so this is taking advantage of a physical property or the state of matter between the two things. The process that separates a solid from a liquid in a heterogeneous mixture is called filtration. Yes, you do need to know that. Brewed coffee is a mixture of ground coffee beans and water. And what process does it use to separate the two? And that would be, you know it, filtration. We're going to cover this distillation, and then that will be the end of this lecture. So tap water is a homogeneous mixture of water and substances that can be dissolved in the water. We add things to water to keep it healthy and safe for us to drink. But one way to separate the water from the other components in tap water would be a process called distillation. And distillation, a liquid is boiled to produce a vapor that is then condensed back into a liquid. And here is the setup, and I hope you can see it well enough. So down here we have a Bunsen burner that is heating our liquid, in this case tap water. We have a thermometer here so we can measure the temperature as this is going along. As the water vapor is created, it will rise through this column, and it'll come over here because this is the only exit point, and so the vapor will have to flow in this direction. We fill this tube here with cold water from the tap, and we put water in on one end and it comes out the other end with some hoses. And then this is colder than this over here, so the liquid will then recondense and it will drip out the bottom over here as water. And this water over here we now call distilled water because we have done this process of distillation. Something will be left behind in this container, and that would be the various things like fluoride that we put in our water. We add some chlorine to help inhibit growth of bacteria and fungi. And so here they're explaining what I've just explained to you. And this is called the receiver flask, or the condensing flask. The liquid in water is collected, and so this is because boiling points are much higher for the solids than they are for the liquids. And so we can use a difference, even if we had two liquids in this container. If we had, let's say, ethanol and water, ethanol has a lower boiling point, and so we could monitor this temperature and keep it below 100 degrees Celsius, and we would have ethanol collect first and water would be left behind. Okay, we're going to stop here. Thank you for listening. There will be another part 2, section 2 lecture. Thank you.